Yeah.
So I
Search
check my
formatting function
Yeah.
and translation.
Yeah. Which ones are you looking for? That morning you missed, was it?
no.
Or are you just looking for them all?
Yeah.
They should all be
There
there.
were a few of them, but like, okay, so which day was it? I think it's either Tuesday or Wednesday. We had which day do we have math and chemistry? I'm sorry, I'm sure it's Tuesday.
Yeah, isn't it?
I think it's that day that I can find you as well.
Okay.
I'll look again.
Yeah. Because the way it works is, the videos I still have to upload, I keep them in this folder, and all the videos you can see are from today.
Yeah.
So I don't have anything, I don't think. That's this one now. These are not the correct ones. Right. Anyways, we'll take care of that later. So, materials now. You have pen and paper, of course. Materials. So, materials is a good chapter. Atoms is a good chapter. The only thing that's a bit tricky in this semester is fields, which is the middle part of the course. But materials is quite nice. It's not too difficult, and there's not too many formulas. There's not too much to learn. I think it's a good question in the exam. Did I open this? No, I didn't. Yeah. Yeah, this one here is, you can see it there, it's 9. And the next one, the fields, is 10, so it's kind of the bigger one. And the atoms is 9, but I think I need to add one more in. So a big difference in semester 2 is that they're more evenly balanced, whereas in semester 1, what took up most of your time? Mechanics, and the least? Waves. Whereas semester 2, you were asking me about enough time and all that. Semester 2 is more steady pace than semester 1. Okay, so anyways, on to materials, and the first topic is density. This is actually something we talked about in mechanics. You might even remember the formula. No and no. Density is mass over volume. So we've seen the formula already. Density rho is mass per unit volume, that is mass over volume, and the dimension is mass per length cubed, with units of kilograms per meter cubed. So what does this tell us exactly? I think it's worthwhile writing this down again, since I didn't get the right answer instantly. Oops, sorry. Okay. Do you have that, guys? Yeah. Next. What does this tell us exactly? So, does anyone want to try and explain density like its meaning? So if I say something has a high density, what exactly am I saying about it?
Big mass and small.
Yeah, a lot of mass in a small space. Low density? Yes, yeah. Little mass in a lot of space. Yeah. So some materials have high density, of course. Can you think of materials with a high density? What would have a high density?
The gas.
High density, not a gas.
The gas in a
cylinder. No, you'd be surprised it's not that high. It's pretty high, but something else. Anything else? High density, something that has a lot of mass in a small volume. What do you think? Or is it easier to do the other one? Low density. What would be a low density?
Paper.
Air.
Paper, yeah, not that low. Air would be very low. Very low. Gas, air. What else? Water, I would say, is medium density. What else would be low? Think about it. Something that could be quite big, but not quite heavy. Big, but not heavy. Come on.
Balloon.
Huh?
Balloon.
That's air.
Yeah, it's still air, but that's right. A balloon would be big, but not heavy. What else? Think about something to do with post, mail. Do you know that white material for packing? You know, you buy a laptop and maybe there's this white foam around it. Yeah. This is very low density. The styrofoam is what it's called. This would be low density styrofoam. And something high density, you know, would be something like concrete or something like lead. You know lead, this Pb, this element. Do you know lead? I don't know if you've done it in chemistry. Pb is the element, lead. It's what used to be in pencils. Used to be, yeah. It's a very dense material. It's really, really heavy material. Do you know this material? It's poisonous. That's why it's not used in pencils anymore. You might have heard of lead poisoning. It used to be used to make pipes until they realised it's probably not good to have water going through pipes that is poisonous that you're going to drink. So instead we use something like copper or steel or something like that instead. So examples would be like gold. Gold is a very high density because a small bit of gold is very heavy, for example. The density is huge. Look at that. 19,320. Now to put that in context, the density of water is 1,000 kilograms per meter cubed. Gold is 19,000. So it means like one cup of water and 1 cup of gold. The gold will have 19 times more mass than the cup of water. So it will feel 19 times heavier. So it's a lot. That's really a lot. So that's a high density. Now, very high. Now, what I would like you to do as a little bit of revision from semester 1 is I want you to convert kilograms per meter cubed into grams per centimeter cubed. And before you do that, just tell me, in chemistry, have you talked about density? No, it hasn't come up? But you use grams and centimeters in chemistry rather than kilograms and meters, right? Or, yeah.
You haven't done any calculation of this, like, we have grams and grams it's always in grams, kg.
Yeah, so that's what I want you to do here. Convert this into grams per centimeter cubed. See if you remember how to do that. I'll tell you which lesson it was. It was the first lesson. Yeah, grams per centimeter cubed. So don't tell me the answer, just tell me if you have an answer. You have an answer. Do you have an answer, Mir?
Maybe.
Maybe. You're not committing to it. Good. Right. Musharif?
Not yet.
Okay. 1 more minute. Right. Mir, what's your answer?
1.932 to the
10 power.
13.
That is a ginormous number. So you know that's wrong. What's your answer?
19.32.
Okay, and Musharif? Come on. Chop chop.
19.32000.
That's your answer? You didn't just say that because that's his answer?
That's not my answer.
You said 19.
0.320.
Yeah, that's
Yeah,
the same thing. Huh?
19.32000. grams centimeter.
You said 19.32, and you're saying
19.320. No, not with the.
no point.
No point.
Ah, you have the right answer. It's 19.32. 10 to the 13, you know that's wrong.
Multiply by 1,000 and divide by 100 cubed.
No, yeah, but you're doing it the way you learned in high school, which remember I said makes me sad. Remember? Sad. Let me remind you, 19,320 kilograms per meter cubed. Yes? That's 19,320 times 1,000 grams per meter cubed. And if you remember, here we want centi cubed. Actually, let me just clean that up a little bit more. This is per meter cubed. So this is 19,320 grams per meter cubed. I don't want meter cubed. What do I want? Centi cubed. Yeah, centimeters cubed. So I put a centi here and a centi here. So now I get 19,320,000 times 10 to the minus 2 cubed grams over centimeter cubed. So I get 19.32 grams per centimeter cubed. Now do you remember doing this like this? No.
Exactly the same.
No, you didn't do it exactly.
My multiply, I did divide.
What else?
Same way, like -2 and then bracket.
Yeah, but the pity I can't give you any marks for that in the exam because it's way off. Alright, so good job, Iad. We have this one, 19.32. You do remember doing this way? Yeah, okay. He needs to write it down. You didn't quite do it this way, or? Yes. You went back to high school, right? Yes. Okay, I need to continue here. Right, so that's gold. Some materials have a low density, like helium. Do you know helium? He, for example, has a density of 0.179 kilograms per meter cubed. Now, again, to put that in context, what's the density of water? Do you remember what I said it was? 1,000. Does anyone remember the density of air? We mentioned that in semester 1.
1.3.
No, but you're close. It's roughly a kilogram per meter cubed is the density of air. Roughly. It's kind of like 1.2 kilograms per meter cubed. Anyways, helium is a very low density material. Pretty small, right? Okay. So what's a medium density? So I consider medium density water, which is 1,000 kilograms per meter cubed. Now actually it's an important value in science, the density of water. It's very important in biology, the fact that the water is this level of density. I would consider it medium. But the density of water is so important. Often we give density in terms of water. For example, the density of gold is 19 times more than of water. So my point is, water is such a common standard for density, that often everything is compared to water. So we can say gold is 19 times more dense than water. So this gives us our next idea, which is called relative density. It's the density compared to water. So the relative density is the density with respect to water. That is, relative density S is the density of the object divided by the density of the water. It's a proportion.
Like the relative index.
Like the what?
reflective index. Uh,
Yes, the refractive index is the speed of light in...
What you mean?
Yeah, exactly, yeah, it's a relative thing. I don't know, do you have anything like this in chemistry where you measure one thing relative to something else?
Relative atomic mass.
With the carbon.
Perfect. It's relative to carbon. Carbon 12, yeah, perfect. So it's not, relative atomic mass isn't mass, but it's how many times it is the mass of carbon 12, yeah. So it's a similar idea. Power back. Oh, hold on, what's it doing? Stop doing stuff. Okay. No, near, that one. That one. This way it won't strangle you being across your neck. Okay. Can we rest the box on the table? No, not that. No, the box. And there we go, we're good. Okay. I just need to unlock it now. I'll leave it. No, that's fine. I don't care about that. It's the box that I'd be worried about. Okay.
Recently came from China.
What?
It recently came from China airport.
Where? The battery? The box? Yeah. That's a replacement of the original, and the battery's a replacement of the original. Like I said, I'll stop using it once I can't squeeze any more life out of it. Okay, you wrote this down, Rashid? Yeah. What's the units for S?
Nothing from nature.
Nothing.
No units.
They cancel.
Yeah, they cancel. It's dimensionless. Now the reason it's important, one reason it's important, it's used for buoyancy. Does anybody know this word, buoyancy? Buoyancy means like the force that makes something float in water. Like wood floats.
Yeah.
Oil floats. The reason things float, which we'll talk about later, is because their density is less than that of water. In other words, if S is less than 1, like wood, it will float in water. If S is greater than 1, like gold, it will sink. You get the idea? Yeah? What would happen if S equals 1?
In the middle of the road.
Half of it's in, half it's out, or... It doesn't neither float nor sink. It can kind of freely move around with the water. It will just kind of move.
Nothing, the bottom and nothing else.
Yeah, it could go to the top, it could go to the bottom, it'll just move around in the water. It doesn't prefer to go up or down. It just moves around randomly, which is something we'll talk about later as well. Okay, continue. So here's some values of densities. For example, gold is 19,320 and relative to water is 19.32. Silver is 10 times that of water. Nickel, do you know nickel? It's alloy. Salt water, now this is interesting. Salt water is a little bit more than water. So by salt water I mean like ocean water. It's a little bit more dense than, say, tap water. Fresh water is 1,000. This is the water that you would drink. Ice is less than 1,000. It's less than 1. This is why ice floats. Because this is less than 1. Ice floats on water, doesn't it? Yeah. Alcohol floats on water as well. Wood, of course, floats on water. And air is the lowest in my table. When you compare it to everything else, you can see how little it is. Now, you'll need to write this table down because for some of the questions you need to know these values.
This is the same idea like sensitivity.
Well, table. Okay. You writing that down yet? Got it? Yeah. Right. Here is a question that I think you should be able to do because it's not too involved. So just before you write it down, let me just explain what's happening. First, I want you to change litres into metre cubed. We did this in semester 1. Then I want to know what is the mass of 1 litre of fresh water. So what you do is you go back to the table, you use this value, and you use the formula density equals mass over volume. So then what does mass equal in the formula?
Density over volume. Density volume.
Yeah, density volume, yeah. So if you know the volume, which is part A, and you know the density, which is in the table, then by multiplying you can get the mass. So you have to do that for part B and C. Then part D, what's the combined mass? So that's add B and C. And then part E, what's the combined volume? So again, if it's 1 litre and 1 litre, then it's 2 litres, so it's just twice this number. And then finally, what's the combined density? So it's the combined mass over the combined volume. And note volume adds, so volume total is V1 plus V2. Provided no change of states or weird stuff happens. So like in chemistry, if you have a litre here and a litre here and you mix it, you should have 2 litres, unless there's some kind of chemical reaction where some of it's turned into a gas. Like what if you mix a acid with a base, then some of it leaves and becomes a gas. Okay, I don't think this is too bad. If you can try it before I do it. Okay, so see what you can come up with. How are we doing with this one? Going okay so far? Tell me when you get to the end, Iad, or Mir or Sharif. Got an answer? Okay, I think I need to hurry you along here. Iad, which part are you on?
E.
Huh? E?
Combined problem, yes.
Yeah. Okay, you're nearly finished. Mir?
D.
Okay, Mir Sharif?
Mhm.
What answer did you get at the end?
1000 plus 1000.
Oh, just give me a number. What's the number at the end?
2007.
Huh? For part F?
Yeah.
F? No.
No?
No. Did you get an F, Iad? Got an E?
I got 1000.
Okay, time for me to do it. So part A, what did you get for part A? 1 litre is how many metre cubed?
1000.
It is not 1,000 metre cubed. Think about how big a litre is. Show me with your hands how big a litre is. A litre, not a metre, a litre. A litre of Coca-Cola. You go to the shop.
Oh.
Yeah, wakey. How big's a litre? Show me. Yeah. And how big's 1,000 metre cubed?
From there to the...
So are they the same? What did you get?
10 to 9.
10 to the plus 9. Ay, crumba. What?
10 minus 10. Minus 3.
What?
I
Any?
got 1,000.
1,000. Right. Okay. How many litres in a metre cubed? Do you remember this? 1,000 litres in a metre cubed. So that means if I divide by 1,000, 0.001 meter cubed is a litre.
Isn't it? Okay, so 1 liter is 1,000 centimeters cubed as well. Right?
1 litre is 1,000 centimeters
Yeah.
cubed?
But including the
1,000 centimeter cubed. Yes, it is. Correct. So if you want to do it that way, is that how you try to do it?
Yeah.
1 litre is 1,000 centimeters cubed, which is 1,000 centi-cubed meter cubed, which is 1,000 10 to the minus 2 cubed meter cubed, which is 1,000 10 to the minus 6 meters cubed, which works out to be 0.001 meter cubed. Yes? What went wrong? Where did it fall apart?
Third.
The minus 2 or the minus 6? Minus 6. You said 9, 10 to the 9. You said 10 to the 9. Did you use plus 6?
I did 1 liter is equal 1,000 and cube, so I multiplied 1,000 to the power 3.
My heart. Okay, can I go on to the B part?
Yeah.
So what was I looking for in B? I wanted to know what is the mass of a litre of fresh water. So density is mass over volume. So that means mass is density by volume. What is the density of fresh water? It's 1,000 and the volume is 0.001. So the answer is 1 kilogram. And then part C, the mass is density by volume, which is 1,030 by 0.001, which is 1.03 kilograms. Part D, what is the combined mass? The total mass would be 2.03 kilograms. Part E, what's the combined volume? It's 2 liters, which would be 0.002 meters cubed. And finally, the combined density is the combined mass over the combined volume, which would be 1,015 kilograms per meter cubed. Okay, we might need to write that down. Go ahead.
What is the density?
There it is at the end.
So what is the combined over that?
You start at 9 o'clock?
Okay.
Oh, so why so tired?
Okay.
Do you have lunch? Frappuccino? What you have?
I went to the Pakistani shop just to know
Ah, yes.
the curry type.
Yeah. Okay. Do we have this? Okay. Yes?
Yes.
Okay. Right, this isn't a question to write down, it's one for you to think about. A student places 10 grams of ice into a bottle of water. The student closes the bottle and there's no free space. That is, the ice cube is held under the water. So what you've got is, you've got some water, you put some ice into it, it's full to the top, and then you put a lid on it. Can you picture that? Yeah. Then the bottle is left out and the ice starts to melt. So I want to know, when the ice has melted, what happens? A, the volume increases and the bottle breaks. B, the volume of the water in the bottle has remained unchanged, so nothing happens. Or C, the volume of the water has decreased and now if you open the lid there's a little space at the top. So basically, does the volume get bigger, stay the same, or smaller are my three choices. So what do you think? You're going with smaller? Any other opinions?
Wait, so about the dissolved water first.
Ice and water mixed together. Like ice water, yeah.
Okay, so like half and half, we say?
Let's just say half and half, yeah. Half ice, half water.
Less.
It's less, yeah. So it's because the density of ice is smaller than water. When it turns back into water, it takes up less space than when it was ice. Because low density means higher, yeah. Next question now. So let's see. Some silver jewelry is mixed. Some silver jewelry is actually a mixture of silver and nickel, not 100% silver. So I want to know what's the density when you mix 10 grams of nickel with 1 gram of silver. So, you have some piece of silver, it's actually 10 grams of nickel and 1 gram of silver. What's the density of the mixture? I'll let you try this before I do it, see what you can come up with. It's a little bit like the last example you did. You need to look at the combination of mass and volume. That's my hint. See what you can come up with. You'll need the table as well again. Yeah, maybe actually, I'll just change it. Get an answer, me, Sharif? You've given up? It's not going to happen?
Yeah.
Mir and Iyad haven't given up. Maybe you're thinking they should give up.
No.
I hear Adnan's sick. Were you talking to him?
He said hi.
He said hi. You tell him I say hi back. Oh, you met him yesterday? Ah. So does that mean you're infected now with his sickness?
No, I'm immune.
You got a vaccination?
Well, I had chickenpox before.
You had it before? Yeah, okay. Yeah. I had it as well, so I should be okay. Have you had chickenpox before? You had it before? Great. Yeah, okay, so then actually he could be in class, although he might be infecting the other students in chemistry. You know you can get a vaccine for chickenpox. You know that? That's what they do in America. They vaccinate for chickenpox. I think it's interesting, but it seems unnecessary since it's not I know it's annoying, but it's not a particularly dangerous illness. Okay, how are we doing here? We have answers or no answers? You have an answer? Yeah, what did you get?
Okay, 99,500.
99 or 19? What did you say?
99.
1,000? 99 seems awfully big. I think you might have forgot to divide by something. It sounds like possibly. if I was to guess. Let's have a look. So the density of the mixture is the mass of the mixture over the volume of the mixture. Now the good news is we know the mass of the mixture. If we have 1 gram mixed with 10 grams, what's the mass? Well, it's 11 grams. But we don't know the volume of the mixture. What's wrong? Yeah, you're looking.
No.
Is it making sense?
Yeah.
Do we know the volume of the mixture? No. But we can say it's the volume of the silver plus the volume of the nickel.
Okay.
But you might say, well, but we don't know those either. But we have this formula, density is mass over volume. So what's volume? Mass multiplied density. So you could change this into 0.011. The mass of the silver times the density of the silver plus the mass of the nickel times the density of the nickel.
It should be mass over density.
Oh, so sorry, thanks. Thank you, Mayor, I screwed that up. Mass over volume. So volume is mass over density. That's what you were saying, thank you. So that's 0.011 over the mass of the silver over the density of the silver plus the mass of the nickel over the density of the nickel, which is 0.011 over silver was 1 gram and nickel was 10 grams. What's the density of silver on the table?
10,500.
And then of the nickel? 8,900. Right, so let's hit that into the calculator and see what we get. So this comes out at 9025 kilograms per meter cubed. Proceed or not? Proceed, okay. So I'm thinking we could do these now because as you can see they're not terribly long questions. If each question takes you 2 or 3 minutes, then I'll do the answers and then I think we'll finish. I think that'd be fair enough. Then we already have the first lesson done in the new chapter. Yeah? What do you think? We'll do these now. There's only 5 of the questions and like I said, you can see that they're all sort of this length. You know. So if we were just to look here, the first one, I want the weight. And I give you the volume and you know it's wood. So you know the density of wood. A trophy is made of gold and silver. What's the density? That's like my example with the nickel and silver. This one is a little bit tricky. This one is okay and this one's okay. Yeah, you might have to think carefully for these. Okay. I'll let you try these for a few minutes, then I'll give you the answers. Yeah? Everybody looks exhausted.
No.
What do you mean no? Huh? It's not quite the weekend. You're nearly there. Yeah?
Okay, so the first one, I get the volume by multiplying.
Yep.
Then I multiply by the density of wood, right?
Let's see, you want the mass, is it? Density is mass over volume, so mass is density by volume, yeah?
Okay, and then G.
Yeah. Exactly.
That's the number.
What's a huge number? What did you get? 100,000 newtons. Will I tell you what you did wrong? You forgot to convert centimeters into meters. Work. Alright, I'll let you work on that for a few minutes. I'm starving, I need to get like a cookie or something. Unless you happen to have one. No?
What?
Yeah, one was always good for a little bit of food. Yeah, you guys got nothing for it.
I have a Mars bar, does that work?
See, I would love to have a Mars bar, but I feel like I should be a bit healthier because I had a Twix for lunch. I don't think my wife would be happy with me if I had a Twix and a Mars bar for lunch. I have to eat at least decently sometime. Right, I'll be back in a minute, and then, yeah, see how you get on, and then I'll give you the answers, and then it'll be weekend. Okay, so, yeah, so just try and focus on these questions for a few minutes. Focus.
Yeah.
You're talking about physics, yeah?
Yes.
Yes.
Cup by 5 is by 1.9, right? Low density critical N.
So the D to be correct. The trophy is made of
क्या रकम
30.
70
Wait.
لا لا ما ما كاتبة خلاص اسمع ما أنا بجيب أجيبها جيب جيب
3190.
The trophy is made of 100 grams of gold and 100 grams of silver. Give him a
ada density chapter gold first thing ada density chapter silver
having a volume.
and
And then we'll see. No, no se sabe, ¿qué más se nace?
कितना में ना
I think it's an array. 0.011 nace.
mass of the you know is condition silver
No sabe, ¿verdad?
mass of the silver
First answer for second.
Yeah, we're doing that now. What did you get?
7
How did you do it?
The same way we did
The way we did
yeah.
before. Okay, so, alright, so you got the combination 0.1 over 19.30320.
Yeah, so
Plus,
it's faster and then I find the volume of this, add
add them together and
together and then the mass together. And then I found
the mass together. Oh, so
yeah.
it's just 0.1 plus 0.2.
Yeah.
And then 0.3 over the combination of that.
The velocity.
Wait, why did
The
you do
volume.
3? Wait,
Why 0.1
look at that.
Mir
A different number.
Mir I don't think you are certain it's right.
huh?
I don't think you are right.
How?
Why not?
Because that you should get this is the previous one.
Yeah.
So this is my answer. So this is the math. This is the
0.3
Yeah.
over. Yeah, see, okay, so this number is different. That's what I'm saying.
This one.
I think.
Somewhere.
Oh, see.
I have done like separately.
Yeah,
Like
yeah,
my
I-
mass is total mass is here, then I
That's
find the
fine.
volume of the gold and then volume of the silver.
Yeah,
I
yeah,
did
yeah,
both
yeah, right.
with more
But,
rate to rate.
but the answer is different.
Why?
I mean, look.
How
Did I
much
write
did
anything
you know?
wrong?
12.5. 3 point, like I think it's the decimal thing.
Oh, did you? Oh, did you
Yeah.
round it up? Oh, okay,
Yeah.
okay, never mind.
So it will be like your answer will be close like to 7,000
Okay,
or
okay.
something, you know.
0.3 over answer 3 gold. What the shit? What's your answer final?
11,878 something. It's in 7,000 or not? How much you got?
I don't know.
Mir yeah
0.1 over 1930 plus
तुम कितने स्टाइल का बना
9 plus 0.2 over
No, the 5
10. Okay?
I am sitting my hand.
Right, 0.3 over answer. What?
Wait. Let me check.
Come
0.1. Five
No,
minus
no,
5
no.
another 10 minus 6. 0.2.
Huh?
0.2. 0.5.
And plus 6
1.94 into the 10 minus 5 plus 5.1. Yeah, you're right. I have mistaken there. Plus 2.4 to 1.5, yeah, volume is
No.
the volume. And then
Oh, the road.
1.5
Sorry.
to 1.5 over 10 minutes. Your answer is right, yeah.
Okay. The teacher is enjoying a glass of wine. He got it from the student.
You got it from the he wants the glass for yeah.
Sorry. And notes about the information state and we will 75 centiliters bottle which is 14% alcohol by volume. 4. A liter of alcoholic drink which is a mixture of alcohol and sugary sweet water like liquid. As a matter of percentage of this drink. This guy is an F equals P over P object over P water. Valente
Multiply by 3, yeah?
Yeah.
Really?
I think so. I mean, it's relative. When we get the relative atomic mass, we divide and multiply by 100.
Yeah, you
So this is the
divide the,
percentage. How much
density
percentage?
of the, okay, what is the density of the?
Yeah, we need to get
Okay,
density of
it's
the.
valid.
Yeah, we have a mass. We don't have the volume.
So we have the
We have the
density.
density of
We have the
alcohol.
density of alcohol, so we can find the volume.
Okay, what about the sugary sweet water like liquid?
We should be volume.
But it's not what we can't say it's 1,000.
Yeah, sugar, there is sugar. There
We
is no
don't.
sugar.
There isn't.
I assume that alcohol is sugar, maybe.
A liter.
What is the threshold? No, no.
We know it's 1. Wait, it's 1 liter. That's the volume, isn't
Mm.
it? 0.001 meters. Okay.
Saying assuming the 86% is non-alcohol has a density of that of salt water.
We know the density of salt water.
Yeah, so
But this is different. What's sugary sweet water?
the non-alcohol part is probably something like a sweet cigarette. So after that saying assuming the 86% is non-alcohol has a it's saying that assume that the sugary water is the salt water.
That's two different questions. I know, but that's two different questions. Do you think because it's 3 and 4 they have something to do with each other? Is that what you're saying?
Yeah, because there are two percentages given. One, the 35 centimeter is given. Then we have to find this shit.
We're doing 4 because I don't know what this is.
You're doing, I'm talking about 43.
What percentage of this drink is alcohol?
A liter of an alcohol drink to a mixed alcohol blend.
I don't have that. 976 times 0.001 is 0.976. This is the. Wait. No, I should divide. 0.001. 967,000. That's the density. Then what?
A liter of an alcohol drink.
The density of what?
We find the density of alcohol drink. But the stage should be open. Or the mass.
I have a mass and I have a volume, that's a liter. I can get the density by dividing 976 by 0.001 because it says a liter.
Yeah.
So
So we have the density of
the whole thing
the alcohol drink
and the alcohol.
and sugary sweet water like liquid as a
They're
mass.
together, they make a density of this.
How do you know? MOV.
Because, MOV makes this. I know alcohol by itself,
But the mass given here is 976 is not alcohol, it's mass.
it's everything.
We should add the component of the alcohol.
Green.
No, okay, no, we can do this. Okay, the mass is 976 of the whole drink.
Yeah.
Okay? It's 1 liter, so I can get the density of the whole drink, which is this. Okay?
Yeah.
I have the density of alcohol by itself, and it's 789.
I think we'll compare the density of alcohol with water, relative density. That would be the percentage.
But it's not of this drink. If it's just pure alcohol,
Okay.
then 789. Why? Why am I doing this? No, that's what we want to do. I put over 1,000. It's back to 976. Times 100. I don't know. I lost my way.
Oh, you must be finished with such happy looks on your face. How are we doing?
We're smiling because we can do it.
Confused smile. How far did you get?
Honestly,
Good.
we'll skip 3 and try 4, but
Yeah, fair enough. And how did 4 go?
that's, that's what we were smiling about.
Shall we do them now? Or yeah, okay. This is the best lunch ever. You get it from Lidl. You know Lidl? It's only 39 cents. Just put in hot water. It's very simple, delicious. Right, let's have a look.
Healthy? Healthier than more stuff.
Yes, yeah. You know, it's mostly just dried noodles. You know, it's 54% noodles. Noodles can't be that bad for you, right? Okay, so did you get the first one?
Yeah.
What did I want? The weight. Weight equals mg. M is density volume. G. Density of wood is what, please? What is it? 700. And what's the tree length? 5, 10, 90, yeah? Yeah. And so what's that, please? Does anyone have a tissue? Oh no, I'm good, I got one, thanks. Okay, what's this one? What is it?
30.9
Right now?
Yeah, what? 30.9, yeah.
We did get it.
Why did you sound surprised?
No, because we had it, but then I think I did something wrong. The way you never mind, I got the right answer. That's all that matters, I got the right answer. We got the right answer.
100 grams of gold mixed with 200 grams of silver. What's the density? So, the density of the mixture is the mass of the mixture over the volume of the mixture, which is the mass of the, what's it, gold and silver, was it? Mass of the gold plus the mass of the silver. And then we have density as mass over volume. So volume is mass over density. So this would be the mass of the gold over the density of the gold plus the mass of the silver over the density of the silver. What is it? 100. 0.1 plus 0.2, 0.1 over a big number plus 0.2 over a big number. What's the gold? 19,000. And silver is 10,000? 10,100. 10,500. Okay. What's that, Musharif?
No.
No what?
Just
Yeah.
I did it.
What's wrong? Curry noodles. Do you need to write that down?
No, we did.
Yeah. Do you do it differently or something?
No, okay.
Okay. 3. Right. Your teacher is enjoying a glass of wine and notes that bottle's information. It's 75 centiliters and it's 14% alcohol by volume. And the non-alcohol part is probably something like a sweet sugary water. So assume the 86% non-alcohol is like salt water, roughly. What's the mass of the liquid? Okay, so what I'm saying here is, density of the mixture is mass of the mixture over volume of the mixture. Okay? Now, we can work out the volumes. We want the mass. Okay, actually, you know what? Maybe I'll draw it as two halves. So we have our bottle, and we can imagine it's 14% alcohol, 86% sugary water. This one has density of 10,030 kilograms per meter cubed. This one here has density of, what did I say? Of alcohol, 800 kilograms per meter cubed. How big did I say the bottle was? 75 centiliters. Now, 75 centiliters is 75 times 10 to the minus 2 liters. And do you remember how big a liter is? It's 0.001 meter cubed. So it's small, it's 0.00075 meters cubed. This is the body.
How did you...
No, that's, I'm sorry, that's wrong. Isn't it? It seems too small.
How did you find the 1,000?
No, I guess not.
Isn't it 0.075?
No, I think 0.00075. Well, what did you get?
0.75. 0.0.
Oh no, it should be really, really small because it's a glass. This here is 1 liter. So it has to be smaller than 1 liter because it's a glass. So no, this is the right number of zeros. Do you see how I just replaced centi with 10 to the minus 2 and liter with the, yeah.
Then why did you write that the density is 1,030? From where did you get this?
I said in the question, the non-alcohol part is the density of salt water. Okay, is that okay so far? Now, can I work out volumes? Well, I can, because I tell you this is 14%. So, if I take 14% of that number, this would be 0.000105 meters cubed, and the other one is 86%. That's 0.000645. I got 14% of this number. Yeah?
Times 0.14?
Mm-hmm. Yeah. That's kind of all I need to know, because what was I looking for in the question?
The mass.
The mass. So, what's the formula for mass? Density by volume. Yeah, so it's going to be density of the first one, volume of the first one, plus density of the second one, volume of the second one. It's like two mixed together. So, yeah, just look, take this number, multiplied by this, plus this number, multiplied by this, and we get our answer. That's the answer there. Delicious. You shop in Lidl? Try it. Make sure you get the curry flavour. Speedy noodle. You're students, you want to save your money, don't you? Yeah. Save your money.
How much?
39 cents. Good deal?
Yeah.
I think so. Why, what do you have for lunch?
I want noodles, but it's in the halal shop.
Noodles?
Yeah.
I don't think there's any meat in this.
What do you call that noodle? Andouille.
It doesn't include meat. It doesn't say any meat. It's not like it's chicken or beef noodles. How much are the noodles in the halal shop?
I don't know.
Okay. Okay, can we do number 4 now?
Yeah.
Do you have this written down?
Yeah.
Number 4? Okay. A litre of alcohol, which is a mixture of alcohol and sugar, blah, blah, blah. Okay, so it's the same except we're going backwards in number 4. I give you the mass and I want to know how much of it was alcohol. Now, the reason I'm doing this example is kind of important historic example because this is kind of like how people would have measured the percentage of alcohol in a liquid without having to actually, do any kind of difficult measurements. Let's see what we get. So, we know that the mass is 0.976 kilograms. And we know that mass equals density by volume. Yeah. Now we know the volume. It's a litre. So the volume here will be 0.001. So we know that the density is 976 kilograms per meter cubed. Density is mass. Density of the mixture is 976, and density is mass, which is what we want to know, over volume, which we know. However, what I'm going to do now is just separate this into the alcohol and non-alcohol part. So the mass would be the mass of the alcohol plus the mass of the water over the volume of the alcohol plus the volume of the water. That should equal 976. We should use the formula density is mass over volume, so volume is mass over density because we're looking for the... What are we actually? I forgot what we're looking for. So we're looking for the volume actually, so it'd be more useful to change the top into mass is density by volume. So I can change this into density of the alcohol, volume of the alcohol, plus density of the water, volume of the water, over volume of the alcohol plus volume of the water equals 976. Let's fill in some numbers that we have, okay? What's the density of alcohol? 789. And the volume of the alcohol we don't know. Plus density of water 1030. Volume of the water we don't know. It's sugary water. So, and then on the bottom, volume of the alcohol plus volume of the water. Now we actually know what this part is here, don't we? Because that's the total volume. And what's the total volume? A litre. Yeah. But what I'm going to do instead is, I'm just going to bring this one up to the right and try to make it into an equation. VA plus 976 VW. Now I should take everything to one side. I'll take everything to the left. So 789 minus 976. So that's minus 187 VA plus 54 VW equals 0. Now, if you look at this, you're like, oh, if I can make another equation, I can solve it. So what other equation can, yeah?
How did you do this?
How did I get what?
Oh, the minus 976 minus 789.
Continue. Now, how can I make another equation with volumes? Well, VA plus VW equals... So we can solve this using...
Elimination.
whatever method makes our hearts happiest. But right now I'm just going to use the calculator because I'm tired. Minus 187, 54, 0, 1, 1, 0.001. So when you solve this, you will get VA equals 0.000224 and VW equals 0.000776. Nearly finished. I just want this as a percentage of the total. So as a percentage, it will be 0.000224 over 0.001 times 100. %, is the answer then here. Okay, so that one was a little bit tricky. That would be on the trickier side of things. I don't know if you need to write it down. Will I just leave it here, or do I need to zoom out more? Is this okay? Well, you know what, maybe I'll just put it down here and write just here. Do you need to write this down or not?
Yeah.
Yeah. You wrote it down? Yeah. Musharif? What? No, give me a sentence. Yeah, okay. You need to write this. I like sentences.
I'm sorry, can I?
If it's important, yes. If it's just Adnan, no. You wrote it down, yeah? Okay. What day is your appointment?
Wednesday.
Huh?
Wednesday.
What time?
And 11:45. 11:50 in the morning.
Taking your wisdom teeth out?
Most probably. Sometimes it's very fine. Sometimes it's.
I understand. It's weird. I have one wisdom tooth out and one inside. She said it's stuck inside. She said she can take it out if I want. I said it's okay because it's not doing anything. So just leave it there. There's one here as well, but that came out. That's okay.
Why does it come out? Why is it there?
Our jaws are smaller than they were in the past. In the past, our jaws were bigger. Do you know what I mean? You know, our jaw was bigger in the past. So modern man has a smaller jaw, which means modern man has more teeth than is needed. So it's leftover, you know. Now some people, their wisdom teeth, if their jaws are big enough, it's fine, you know, it'll just come out like a normal tooth. But I think, you know, it depends on your diet, your nationality, your family, many different reasons.
In my whole family,
But then,
everyone has like pain in their jaw.
but then, yeah.
Like my two brothers don't eat. They can't eat.
Why don't they need their wisdom teeth out?
No, but they're like, you know, if they eat, their jaw like, you know, the place here, they feel like, you know,
I understand, yeah. Okay, you got that, Musharif? Right, let's have a look at the last one. Carbon has a density of about 2 grams per centimetre cubed. Humans are 70% water and 30% carbon. What's the density of an 86 kilogram man? So how dense is a 86 kilogram man? Right. So what's the formula for density? Mass over volume. And what's the mass of the man? 86. And the volume of the man? We don't know. But we do know the man is made of water and carbon. So we can say density is mass over volume, so volume is mass over density. So that would be mass of the water over density of the water plus mass of the carbon over density of the carbon. So I suppose we can change it into this. Density of water is 1000 and density of carbon is 2000. But we don't know this sadly, and we don't know this sadly, and we need to know these. Now I think I also tell you that the man is 70% water and 30% carbon by volume. So what I mean by that is 0.70 times the volume of the man is the volume of the water, and 0.30 volume of the man is the volume of the carbon. Do you understand? Now, we also have this here. So it'd be a little bit more convenient if I was to change this into 0.70 times the mass of the man over the density of the man, and this one 0.3 the mass of the man over density of the man. That will equal the volume of the carbon will equal the volume of the volume of the water. Yes. Will that be useful? We want this, we know this. Yeah, I think so, because the mass of the man is 86, and here it's 86. So I can change this into 0.7 times 86. So that is 60.2 over the density of the man equals the volume of the water. And the other one is...
How did they get
0.7 times 86. 25.8 over the density of the man, that's the volume of the carbon. Actually, but it's not. So, you know what? Forget this. I think it'd be more useful if I keep it like this. Density of the man is 86 over the volume of the man. And the volume of the man is the volume of the water plus the volume of the carbon. So, if I write it like this, what I've done is I've made one equation with one unknown. So I can solve this. Now, it's a little bit hard to solve, but if you look here, these denominators are the same, so at least you can add them together. So we get density equals 86 over density, and then 60.2 plus 25.8, that's 86. Oh no! So I end up with density equals density, which is no good. So I've done it the wrong way. Yeah, that didn't quite work out as planned. So let's try that again from the beginning. Let's go to the screen. Okay. What am I looking for? The volume of the man. Right. Density is mass over volume, isn't it?
Yeah.
I screwed it up. I was looking for density, but it's actually I'm looking for volume. So volume is mass over density, and we know the mass is 86 and the density we don't know, but the density of the man would be mass of the man over volume of the man. The mass of the man is the mass of the water plus the mass of the carbon, and then this is the volume of the water plus the volume of the carbon. Right, do we have enough information? I also tell you that this is for 70% and this is 30% as well of the total volume. So that's 86 over mass of the water plus mass of the carbon. That's still 86. I don't like where this is going. Volume of the... No, it's going to end up with V equals V again. Maybe I haven't given you enough information, but I could have sworn last year I did it okay. One more time, and then we'll leave it for the weekend and do it next time, okay? No, we can do this. Be strong, Musharif. Be strong. Right. Density of the man equals mass of the man over volume of the man. Density of the man, we don't know. Do we know the mass of the man? Yes. Do we know the volume of the man?
No, that's what we need.
That's the problem. That's what we want. Good. Right. Density of the water equals mass of the water over volume of the water. Do we know the density of water?
Yeah.
Yes, it's 1000. Do we know the mass of the water? No. Do we know the volume of the water? No, but we know it's 70% the volume of the total man. And then density of the carbon is 2000 equals mass of the carbon over volume of the carbon, which is 0.3 V. Yes. Yeah. Now we'll get there. I just need to think of something really, really smart to do.
Really?
No, but that would be useful.
Yeah.
No, not necessary. Got it now. So if you look here, we have, if we take these two, we can say volume. I can just rearrange it. What I'll do is I'll bring this up to the left and this up to the left.
Okay.
So I get 700. So I get 700 V equals MW. And here I get 600 V equals MC. Yes? So far so good? Yeah? Hang on, let me think.
What's the... I got it.
Oh, I need to think. Do you?
Yeah. 700 V plus 600.
Yeah, that's 1300 V. Yes, we got it! 1300 V, if we add these together, equals mass of the water plus mass of the carbon, 86. I knew it was possible. 86.
I did it.
I was about to get it, Musharif. I was down. So we finish now. Volume is 0.066 meters cubed. Whew, that was a hard one. I'll have to remember that next year. Okay. That's a good place to finish. Now, I'm going to try and not give you homework by doing the questions in class because you're working on your lab report. And I want you to be working on it in your free time. Okay, so if you need something to do this weekend, it's your lab report you should be working on. Alright, let's get out of here.